So what do you mean by the literal meaning of mutual exclusive? Okay, so mutually exclusive also means disjoint. So if you see from the set perspective, right, set theory perspective, if there are two sets, say for example there is a set A and there is a set B, okay, A and this is B, there is no overlap. There is no overlap. Either it can be in this way or it can be, the two sets can be like this. So this is the two possible. When these two sets A and B have no overlap, these are called disjoint or mutually exclusive. Okay, and when there is an overlap, these two sets A and B, these are not mutually exclusive because we have an overlap here, and this overlap is called A and B, and it is mentioned A intersection B. So this is a mutually exclusive case. So what happens? So what do we say? Okay, so let me define it for you. Mutually exclusive. Mutually exclusive means no overlap. Okay, this is also sometimes called disjoint. This is also called disjoint sets. These two sets are called disjoint. They are not joint anywhere. This is no overlap or any common outcomes or any common outcome. Okay, and there's one more thing that we can say for sure is, if we are choosing anything from here, if we are choosing anything from A, then we can say for sure that we are not choosing anything from B. That means in simple terms, if A happens, then B will not happen. That we can say for sure. So if we know that two events are mutually exclusive, means we can say that if one has happened, then the other will definitely not happen. So this is what mutual exclusion means. If one happens, then we know that the other has not happened. Okay, so let's understand from it from the perspective of set theory. We say, right, A union B is equal to A plus B minus A intersection B. How does this come? I hope you know that this is A plus B. So if you want to find what is there, either A union B means this is A or B. If I want to find anything that has happened in this, anything that is either in A or in B, then that is denoted as A union B or A or B. That is given by A plus B minus A, and this is read as A intersection B is read as A and B. That is the overlap part. Okay, so we know from for mutual exclusion, right, what will be this overlap part? This overlap part in mutual exclusion is nothing. There is no overlap. So this A intersection B will be 0 for mutual exclusion. A intersection B is equal to 0. There is no intersection or overlap. So we can say that A union B is equal to A plus B. And in terms of probability, we can say that, okay, we can say that probability of A union B is equal to probability of A plus probability of B for disjoint or mutually exclusive events. And in general, it is A union B is equal to probability of A plus probability of B minus probability of A intersection B. I have defined the terms for you. Probability of A or B happening and probability of A and B happening. This is A and this is B. Okay, this is quite simple. You can find out why it is there. Okay, if not, then we can create a video for that too. Okay, so this is defined. Okay, now let's move to what does independence mean. I hope mutually exclusive events are clear. It's very simple. There is no overlap between two events, and we know that if one has happened, then the other has definitely not happened. So what do we understand by independent event then? Independent events. Independent events. So what is the meaning of independent events now? Let me see. Let me define it for you. So outcome of one event, okay, does not impact the outcome of our other event. Okay, so let me repeat. The outcome of one event does not impact the outcome of other event. Here, so check the wordings. Here what we say, if one happens, then we know that the other has not happened. So that's the understanding. Things are very close, but understand the distinction. If A has happened, then we know that B has not happened. But in independent events, we know that if A has happened, then I don't know anything about B. Okay, so the outcome of one does not impact the outcome of other. That is independence. And here, if I know the outcome of one, then we know what is the outcome of the other. That is in mutual exclusion. If A has happened, then B will definitely not happen. But if the events are independent, then if A has happened, even then I don't know anything about B, what has happened, whether it has happened or not happened. That is independent events. For example, let me give an example. For example, if I toss a coin twice, so first time, okay, toss a coin twice. So first time if I get head, do I know, okay, that what will I get in the second toss? Does that impact the second toss in any way? No. All the events here are independent. Every toss is independent. So the first event, that is the first toss, that is event A, is independent of the second toss and vice versa. Okay. If I toss the same coin second time, I don't know what will happen. So these two events, the first toss and the second toss, are independent events. I hope that is clear. Let me write down the definition that I was mentioning. That outcome of one event does not impact the outcome of another event. Okay, so similarly, if I talk about this, what will be the, so here what will be this probability of A and B? This is the probability of A and B. A and B. This is given by, because both are independent, there's nothing. This is given probability of A into probability of B. Because these two are independent, nothing is happening. There is no relation between A and B, so there is no impact. Okay, I'll give you more information about this when we discuss about conditional probability next, and that will make it more clear. I'll revisit this, maybe I'll explain this again. Okay, but this is what is independent events. So I hope mutually exclusive events and independent events is clear. So to understand again, here mutually exclusive events, if I know one event has happened, then we know that other has not happened. So knowledge of one event tells me that, gives me some information about the other event. So that is mutually exclusive. But in independent events, the knowledge of one event, like tossing a coin, does not give me any information about the second toss. Okay, what will happen in second toss? So both the tosses are independent events. Okay, that is what. Okay, so let's continue. That is what is mutually exclusive and independent events.